I had a coffee.
Basically,
Awesome.
what we are learning today is trying to estimate small change. Alright? This formula is given to you in the formula sheet. We are estimating it's not exactly equal. So use a squiggly line. I'll remind you what we need to do, alright? So, it's just trying to estimate. This is a good technique for estimation. So we need to recall exact change and average rates of change, define and calculate an incremental or approximate change using calculus technique, using the increments formula, which is delta y approximately equals to dy dx times delta x. Define and calculate an approximate percentage change using the increments formula. Use the reciprocal properties of derivatives to solve problems using incremental change. And understand the concept of marginal cost. Cost, revenue, and profit in economics context. And its relation with calculus. So it's the last bit of the differentiation for this semester anyway. After that, we're going to concentrate a lot of integration and then some probability. All right, let's start. So, now, you need to recall the terms like exact change, the average rate of change, and the instantaneous rate of change. All right? So the exact rate of change from x equals to a to x equals to b is basically here, the y, the difference in y value, the delta y. Fa minus Fb, that's exact change.
Yep.
All right? Average rate of change is just basically the gradient. Fb minus Fa divided by b over a. And then, of course, the instantaneous rate of change of x at a is just the tangent to that point. So this is what we have been learning the last couple of years. We're going to use some of these ideas. We're going to talk about just a little increment, little change. How are we going to use the slight change in x to estimate the slight change in y? Now, the incremental change. When the average rate of change of a function is calculated using incrementally small values of change in fx over the change in x, it is called incremental rate of change and denoted as delta y over delta x. It's a really small change. So from the limiting process and first principle, we know that when delta x approaches 0, delta y over delta x approaches dy dx. This results in the increments formula. I'll prove to you. All right? I'll show you what it means. So the next bit we look at, this is the increments formula, dy delta y over delta x approximately dy dx. Don't worry about writing this down yet because you need to know it in a different form. Let's think about the situation using y and x squared. So if we have x equals to 10, fx is 100, correct? Now if we have x equals to 12, fx is 144. Now, not looking at this bit here. What we have done is we have changed. There is a change from x. And the change delta x is 12 minus 10, which is 2. Yes. Right? And then the change in delta x results in the change in delta y, which is 44. Yeah. Correct? Now, so we make a change from 10 to 12 in this case. We call the delta x2. The change in y, delta y is 44. And therefore, we know delta y over delta x is 22. We also know that dy dx is 2x. And then dy dx at x equals to 10 is 20. Now, can we say delta y over delta x approximate dy dx?
No.
Not at this stage yet.
Not
no.
close enough. Not
because 2 is quite big, alright? Yeah. So, let's think about if I keep on changing.
Yeah.
If I go from 10 to 11 to 10.5, 10.2 to 10.1, you can see that the delta x, let's say in this case, is 0.1. Alright? The delta y, if I square that, that'll be square that, and then minus y, that will be 2.01, and therefore you can see delta y over delta x is approximately the same. As you can see, delta x goes closer and closer to 0. You can see that delta y over delta x is approximately the same as dy dx.
Yeah.
Yeah? Agree with that?
Yes.
So we can, therefore, I prove it to you that as delta x approaches 0, we can say that delta x over delta y approximately can approximate dy dx. Right. And it has to be a very small increment of x.
I was asking for the photo instead.
So the increments formula, we rearrange it. This is the bit that will be in your formula sheet. Delta y approximately equals delta x times dy dx. That's the one that you need to know. So we can say that the approximate small change in the vertical value of a function at a fixed point a, fa, can be calculated using the instantaneous rate of change at x equals to a, gradient of the tangent line multiplied by the incremental change in x. Alright, so there's the incremental change in x. That is actually the instantaneous rate of change, correct? That's the gradient at that point. And there's a slight change in x. We can estimate delta y, which is a slight change, the incremental change of y. And we can also safely say that the smaller the value of delta x is approaching 0, the better the approximation. Yep.
Would this be calc-assumed, all of this? Somewhat?
Well, it depends on the numbers.
Yeah. Okay.
It depends on the numbers. I think it most likely will be calcium.
Yeah.
Right. Most likely, but I don't know.
Yeah.
Alright, now let's have a look at example 1. Show the use of increments formula to determine an approximation of the square of 20.02. Now we can either go back to use this table, or we can use delta y is approximately equals dy dx times delta x. Here, when we look at the square of 20.02, what I'm going to assign is a function of y equals x squared, right? Because we want the square of 20.02. So now, 20.02, that's the x. Is that 20 is the x, and 0.02 is the delta x, correct?
Yes.
Agree? So 20 to 20.02, I have the small change, delta x. Now, with y equals x squared, what is dy dx?
2x.
2x. Very good. So now, let's look at the instantaneous rate of change at x, which is 20. So dy dx is 2 times 20, which is 40, correct? And what is delta x? Can we then put this together? Delta x and dy dx. So remember I said delta y, which is a slight change in y, is dy dx times delta x. Alright, since we know delta x, the change is 0.02, we know dy dx at 20, that's 40. Can we estimate the change in y, which is the square of 20 to 20.02? We can just plug that in, plug into the formula. Delta y is dy dx times delta x, which is approximately 0.8. So therefore, the square of 20.02 would be 20 squared plus delta y, and which is 400 plus 0.8, which is 400.8. Now use your calculator and check. Use your calculator and check. If you use your calculator, so I use this increment formula to determine 20.02 if I use my calculator. Alright? Oops, wrong one.
Wait.
20.02 squared.
equals 2.
Oh, it's not 2, 20.02.
Times 40, right? Yeah. So then why do I get 0.4 instead of 0.8?
40.8004. Is that close enough? Yeah?
No.
So I use my dy dx, the idea of small incremental change in x. I estimated delta y. and then therefore I can estimate the value of 20.02 squared.
In the calculator.
That's close enough. Calculator is here. I estimated it as 400.8.
What am I doing?
You go back to the other slide.
Yeah, I'll go back to the other slide for sure. Now, can you try the next one, the value of square root of 197? What is 197 closest to?
200.
200? No.
196. 196.
196. What is the square root of 196?
14.
14, thank you.
Oh.
Yes. So this is y equals to, the function is y equals to square root of x, correct? And you know what is the change? What is the slight change? What is delta x?
1.
Yep. So follow the step and see if you can work out what is the square root of 197. So remember, you should, in situation like this, you should recognize some square numbers.
Times 1.
Yeah, because I wasn't trained using calculator, so when I was your age, I can recognize square numbers until about 1 to 15 for sure, and then I recognize things like 225 and that sort of stuff. Just recognizing a few makes life a little bit easier without when you have a calc free section.
To get 126. Wait, no, that's
One on.
Remember, in this case,
1 on 28.
use approximate.
Incremental
Use approximate, please.
Is it 14?
Yeah. 196 is 14. I think.
So then 28 plus 14.
So you know the value of square root of you know the delta x is 1, correct? So I write down the function that I want to use, y equals to x to the power of half.
14
And you know
plus
delta x is 1.
128.
You should be able to work out dy dx.
It's not very difficult. Does it get harder?
No.
Oh, shit.
So since you know that we are going from 196 to 197, square root of x is 14.
Yep.
Yep, I use a calculator at that stage. It's 1 over 28 anyway, so it's 0.357. And I work out square root of 197 is approximately 14.04.
So if you didn't have your calculator, would you leave your final answer as 14 plus 1 over 28?
Yeah, that'll do.
Yeah.
Yeah, that'll do. Alright. So do you all agree with me? If you use your calculator, yes, it's approximately 14.04. Now, talking about decimal places, I'm actually just marking the paper last night.
2 decimal places instead of the.
There was a question on that you're supposed to evaluate some number to 4 decimal places. A few of you gave me 2 decimal places or 3 decimal places.
I did it, so did I do that?
No, you did not.
Yes, go.
No, you did
I
not.
think I did that.
I don't know who did it, but
It was
that's
me.
come from you who did that. Either 2 decimal places or 3 decimal places. Read the question properly. That is 1 mark lost. That's a specific behavior that we wanted. Alright? Alright, next. Now, here you are given the approximate change of fx. Fx this time is square root of 5 minus x squared. So here I give you 2 different scenarios. One is an increment of 0.5, the other one is increment of minus 0.01. Alright? You must remember your delta x could be positive or negative as well. It really doesn't matter. You need to compare the exact and approximate change. So what I've done is I calculated out the exact and then the approximate change. So the exact change is f 2.05 minus f2. So you know you have to evaluate f2 in this case, which is pretty much, if you substitute 2 in, is square root of 1, which is 1. Now, it's a test of, in this situation, it's not substituting the number, it's actually a test of how you could find your first derivative. Alright? And a few of you actually forgotten the inside of a bracket when you do your first derivative in the test. So make sure that you remember, alright? Yeah, did you all get this? Yeah. So fx is just dy dx, correct? So you know part A, delta x is 0.05. Small change, a small change is 0.05. So therefore, you know substituting the instantaneous rate of change, the at 2 or the gradient at 2 is just minus 2. All agree?
Yep.
And then you can work out, which is minus 0.1 delta y. So that is the approximate change. But if you look at the exact change, is f 2.05 minus f2, right? So therefore, I worked it out to be minus 0.11. That's close enough. 0.1 and 0.11. So a lot of the time, you just want to estimate. So you can use this method to estimate. Can you try part B, please? Which means part B, you will have a positive number, correct? Because then your delta x is minus. You've already worked out your first derivative of 2 anyway. I mean, really, all you need to do is write down delta x is minus 0.01. You know that, you can straight away go into that one. You need to work out the exact change. Follow the same procedure. You should, I can't remember the answer. See, straight away I wrote down because I already know the first derivative at 2. So it's 2 times minus 0.0 is, oh, it's 0.
Sure is 0.02.
It's 0.02. Oh my gosh.
So, stay up late yesterday,
right.
that's why.
I gotta change that. Alright. Slide number, whatever, it doesn't matter. I'll do that. I'll have to remember. So it's 0.02, so my fault. It is my fault. So you can see that it's close
the
enough.
exact change.
So how did you find 2.05
So
squared?
8930
At the bottom.
is when you sub in 2.05 into the equation.
Sub in 2.05. So this is f 2.05.
When x
which is
changes
in here.
from 2
X
to
squared?
2.05.
Yeah, how did you find
So
2.05
you
squared?
sub in 2.05 in the
2.05,
equation,
Yeah, how did you find that?
and then you take
Square?
2.
5. Take
Use a
away.
You take
Yeah, calculator,
the equation
calculator.
and the-
Calculator.
and that's your change.
Calculator.
Yeah, you can't.
I'm not going to work on that without calculators. Not late at night. I'm absolutely not working on 2.05 squared without calculator. I mean, look, when we didn't have calculator, we don't get really curly decimal places anyway. We get pretty straightforward decimal places. All right. I didn't really work out the exact change. So no, I didn't work out the exact change. So I didn't write the comparison. That's all. So you say they are both approximately the same.
Yep.
All right. Now example 3. Here you've got to write the formula. What is fx you need to use? Now you read the question carefully. We talk about the area increase from 100 pi centimeters squared to 101 pi centimeters squared. So do we want dA dr or dr dA?
DADR.
Yeah, yeah, yeah.
What do we know? We know the change in
area.
area.
Change in area.
And we want to look at the change in radius. Look at the RDA.
Can you use DADR and then rearrange?
You can try.
Yeah. So I'm trying.
You can try that. So I arrange it to R in terms of R. I mean, in the exam, you want to make life a little bit easier for yourself, correct? So if you can recognize that you want to change in R, so might as well do that. All right. So you know the RDA. You know delta A. You can work out delta R. I mean, pretty happy if you want to use DADR. I just want all of you to see it. Rearranging it will make life a little bit easier, that's all.
Okay, what questions?
So you're all approximating, that's all. So now what is change in area? Delta A is
The incremental change.
pi, correct?
Yeah, that's sort of.
Actually, talking about using calculator, it was very interesting. Some of you use calculator in the test and come up with the dy first derivative, and it's actually completely different from what I get. I really don't know what number you type in. I really don't know. I don't know what the setting is or whatever. I was like, why? I tried mine 3 times and I got exactly the same thing, so I've got to use my own answer. All right, so delta A is pi because it's 101 pi minus 100 pi, so therefore it's pi. And you can work out delta R, which is the change is about pi over 20. All right, so in this situation, it will be in calculator free, right, June? This will be calculator free because you are answering everything in pi.
Yep.
You are not expected to change to decimal places. All right, happy with that? Happy with the first part. Now the second part, I am going to bring in the idea of percentage change. So the percentage change we are looking at this time, delta y over y equals to dy dx over delta x times delta x over y. That's the percentage change. All right, looking at what is the percentage change of that, estimating delta y, and looking at what the percentage change is. We will, from here, we can estimate the percentage change for delta y. So here, what we are looking at is just changing approximate, we're just estimating the percentage change. Again, using the increments formula, which is delta y equals to delta dy dx times delta x, approximately. I should always use approximately. I'm so used to writing equal. It's always approximate. All right. So now, if delta y represents an approximate or incremental change in y, then delta y represents an approximate percentage change. All right. It could be in decimal, could be in percentage. You know, decimal and percentages, they are both interchangeable. So let's go straight into the example. If P equals 1.5 V cubed, determine the approximate percentage change in P when V is 3%. Now, how do we do it? Get your dp dv out first. All right. So if you get your dp, now we're only dealing with percentages. We are not dealing with the actual number at all. All right. So do you agree with me? Now dp dv is 4.5 v squared. and we have delta P is approximately dP dV times delta P. All right, we don't know anything else, but we do know P, we know the delta V is 3%. All right, see what I do. This time, I'm going to use delta P over P as dP dV delta V divided by P. Here, what you have is, okay. So here, at this point here, what I've done is dP dV I substitute in as 4.5 V squared, correct? I've already derived dP dV. Yeah? And we know P is 1.5 V cubed.
Yep.
Correct? Yeah? I still keep the delta V because we don't know what delta V is. Now here, 4.5 divided by 5 is 3.
3.
V squared divided by V cubed is V. So therefore, what is this? Delta V over V, which is V is increased by 3%. That is delta V over V.
Yep.
Correct? So therefore, it's 3 times 0.3, approximately 0.09. All right, so that's change of 3% is approximately change in 9% for P. Yeah? So substitute the formula in, and then you can actually simplify it and until you get delta V over V. Yeah? Got it? So you can, once you manipulate this, you'll get delta X over X. So what you're trying to do is manipulating this bit here until you get delta X over X, which is the percentage change. Yeah? Got it? So think about how you're going to manipulate the equation here. I missed my squiggly line there. I'll put it back later. All right? So now, this time, the next bit, we're thinking about how we're going to work out delta V over delta P. Now, again, you know you can just use this delta P over delta P over P is approximately 3 delta V over V, correct? Yeah? You can use that. So you know in this case, P is increased by 2%. Can we therefore work out delta V over V? All right? I mean, I rewrote it again this time, 0.02. So it's approximately 0.0067, which is 0.67%. So you don't actually need to know the rate of change. You just need to be able to manipulate the equation until you get delta X over X.
So that's like the percentage, right? So 3 times 0.03
Are you all happy with the procedure that I'm showing you? So what you're trying to do is make sure that you manipulate this bit here, your right hand side, until you can get delta X over X.
It's like changing the
Once you get that, you know that this is the change in X, this is change in Y. The percentage change in Y and the percentage change in X. So I work everything out in decimal, then I change it to percentage.
So it's percentage change. Yeah, we still calculate the change of
All right,
the percentage change. Of
let's try example 5, please. So I make life a little bit easier for you by saying that it is a circular metal disc. So when it comes to the word circular, you know what it means. All right?
Yeah, 9%.
So what is the area of a circle? You should know. Right, you should know by now. It's So you can work out dA dr. Now, how are you going to manipulate it? You know, delta A over delta R is approximately the same as dA dr. Right? I'm going to give you a couple of minutes to work it out. Now from there, I wrote this out. So remember, delta is a small change. So here, you want percentage, change everything, divide everything by A. Correct? So if it is decreased, is minus. If it is increased, is plus. Now you should be able to manipulate your right hand side until you get down to delta R over L R.
6%.
Oh, 0.6.
0.06 or 0.6.
No, 0.006.
Once you get up to that point, you can use the change in delta R over R is 0.3%. Therefore, delta A over A is
by 0.3%.
0.6%.
Or 0.3%.
All right.
Right.
And also do a sanity check.
Alright.
If you increase the radius by 0.3%, you know that increase the radius by, or diameter by, I think I made a mistake. Oh yeah, that's all right. Increase the diameter by 3%. Increase the radius by 3% as well. That's correct. Yep, that's correct. That's correct. So it's 0.6%. So do a sanity check. The area will be bigger than the increase will be bigger than the area of the radius or the diameter, for sure.
Yes. I don't understand this too well.
All right, happy with that? Now, the next bit, we're going to talk about marginal rate of change. So, you need to know that when we look at calculus in economics, we can think about the cost function, the profit function, and the revenue function in terms of X units of a product being produced. All right? This is important. This is not given to you, but you're expected to know that the profit is actually the revenue take away cost. Yeah? You remember from many years ago, profit is revenue take away cost. And if you know the cost function and the profit function, of course you can work out the revenue function. If you know the revenue function and the profit function, you can work out the cost function. Correct?
Yep.
It's interchangeable. Now also remember one thing, if you've got this is a function, if I derive the first derivative of px, that is equals that minus that as well. The first derivative of revenue, take away the first derivative of cost. All right. Now, let's look at the marginal cost of CX, the cost. Let's consider cost only. There's an instantaneous cost per unit when the X unit is being produced. All right, that's marginal cost. You're producing one extra unit. Per unit, you produce so many, and the marginal cost of producing another one. All right, you're only producing one more. So here, in this case, cost, profit, and revenue. This time, delta y is approximately the same as dy dx, because delta x is equals to 1. You are actually producing one extra unit only. All right. So here, you're using this increments formula. However, delta x is just 1. Everything that applies to cost applies to the revenue and profit as well. All right. So this is per unit. Therefore, you're looking at just one unit. Delta x is only 1. Oops. Forgot.
Oh, you got extra time. Oh, marginal rate of change per unit. Yeah, so the change of x would just be 1. So 1 unit change. Because the questions are only when there's like one more unit being produced.
All right. So one more. This time delta x is one more. So delta y is therefore the same as dy dx. Or in terms of marginal rates of change for cost is therefore dc over dx equals to delta c. All right, we're talking about cost now. So y is cost. Same with profit, and same with revenue. All right. Delta x is 1 per unit. So marginal cost, marginal rate of change, cost, profit, or revenue is 1 extra unit, the extra unit. 2 more examples, and that's it for the week. It's been a long week. I know you've all got tests and stuff like that. All right. Next. So let's have a look at this. The total revenue are for the sale of X item is given by that. We're just talking about revenue. Don't worry about cost. Don't worry about profit now. So determine the average revenue if 200 items are sold. So what do you need to do? Average is
dy dx? No.
What is average? Average is
Average
you work
rate of
out the
change.
whole number and divided by 200. R200 divided by 200, so the average revenue per item. We're talking about now per item. You need to look at 1. All right, you need to look at 1. So it's therefore is R200 divided by 200. So that's the average revenue.
Oh.
Average revenue, yeah. You are looking at the revenue of one item, and then the marginal cost when there's extra item produced or sold. All right. So look at R200. So you make a revenue of $4,600. And then of course you work out what dr dx is, or r dash x. And then the average revenue is 4600 over 200, which is $23 per item. Now, here, part B, determine the revenue increase if 201 items are sold. So delta x is now just 1. So basically, you need to work out the instantaneous change at 200, and that will give you your revenue increase is $21 per item. All right, that's marginal because you're looking at one item, one extra item. Now, example 7 will take you to everything, including the profit, cost, and revenue, and we should be able to finish it in about 5 minutes. All right, let's have a look at example 7. Now, you have given the cost C of producing n items is given by this. Part A is exactly the same as what I did just now. So can you try that, please?
So,
Yep.
for 6B, did you just sub in? Oh. Would you sub in for 6B? Did you just sub in 201?
You need to think about what. Okay, each item is sold for $9. What is the determine the number of items?
No. This is 6B.
6B.
Last question.
Delta x is 1. So it's just
Oh,
so
yeah.
delta x is 1. So delta y is dy dx. That's it. At that
Okay.
point, the rate of change at that
Yeah,
point.
yeah.
So you multiply by 1. You can really. The term is
Yeah.
there, but it's just 1.
Yeah, okay. Yeah.
All right. So average production cost per item if 100 items are produced. So you should be able to work out from example. What is C100? And then C100 divided by 100. That's per item. Average production cost.
$9.
And then what is the marginal cost if you produce one extra one?
6B. I think it's 21. I didn't do the math. I just copied off the board. Right, I can do it for you right now.
So hopefully we got the
Yeah,
same
it's
thing.
21.
Average production cost for 100 is $9 per item, and then if you work out the extra one is $7.50, approximately $7.50. All right. Part B involves thinking about the revenue.
So how is $7 change?
It's just it costs for 100 items. Produce each item costs $9 to produce, and then the extra one, so one more, the marginal cost. You produce 101 item, it's just $7.50 for that producing that extra item.
If you use that formula, change your y, dy, dx, change an x. X is just 1, right?
One.
Because you're only doing
Yep,
one more
yep.
item. So you just, all it is just the derivative. Subbing in 100.
So if it said the changing cost of when the 101st item is produced.
It's just a marginal cost, which means
That's
to
the
produce an
percentage.
extra one,
It's just
the 101 item, it costs $7.50 instead of $9. That's all.
That's just
So if you think about factory things, it just go,
Yeah.
it will decrease.
so when you
Alright? So up to a certain point, you just look at what is the decreasing cost.
It's just the change in whatever the
Alright, next one.
Oh, break even.
The next one you got to think about the revenue. So the revenue, listen, is $9. The number sold is 9 times n, correct?
Yeah.
Yeah, agree? Now this one is a tricky one because you need to be able to use your solve function or your calculator. So you know that Pn is that. Alright? The profit. For profit, if you want to break even, profit is 0, correct?
Yeah.
Yeah? So you can solve it. Break even point. That equals to 0. And you can see that it could be 100 or 190. So you draw, if you use your class pad to draw a graph, it will look something like this. It did look something like this for me. I think it looks something like this. Alright. That's where the break-even point is. So you use your class pad. In this case, you can solve it with class pad, sorry. Or you can use solve to solve it.
Wait, so wouldn't you reject the 191 solution because technically you're going to be
Not-
under $0?
No,
Yeah,
you'll
it's
be
still a
over.
break-even point.
No, but since you're rounding it to 191,
Yeah, that's true,
Still
but
less than zero.
you're doing approximation. All these are approximations, is that right?
Fair enough, yeah.
Yeah. So the break-even point, well, it's really speaking, break-even point is not even this point. We should reject that. That's correct, because the first point is break-even,
Yeah.
and then you start earning money to the maximum point, and actually that's not really a break-even point. This is the break-even point.
Yeah.
Got it? So strictly speaking, yeah, I should reject this. That is not break-even point, because at any point after that, you're actually making money, and that is start to not make any more money and losing money. So it's
Yeah.
not actually a break-even point. So it's actually only 100. So I should get rid of that. Happy with that?
That's true.
Yeah.
So if it says break even point, you only choose like the first time.
It should be,
It's
because
only
yeah,
the
if you
first
draw the
time.
graph, yeah, the first time you hit from not making any profit until there's break even,
That's the
and then
first
you start
time.
breaking profit and coming back. So that is actually, I interpreted incorrectly. That's not a break even point. So the 191 item shouldn't even be there. It's
Yeah.
only the first point. All right. So therefore, the next bit you can do from there. You go for working out your PN equals to that, and then work out if you want the profit to be 6. That's it. N equals to 16.
No, but even if you
That's
did,
all.
Yeah,
it'd still be more than 0. So you can't, don't solution. It's going to be a whole item.
So let's say it was 1.
All right. So the marginal cost is 6 because that's PN. That's 6.
Yes.
That's all you need to do.
Yeah, I mean, both
All right.
ways.
Really,
you can argue
this is
to round up or down, because you're
delta
not going to
B
be breaking even.
over delta B
Because
is
if you
approximately
round
the same
down,
as dp
you're going to be above 0.
dn times
profit.
delta n,
If you round
and
up,
delta n is
then you're gonna be,
1, and you want that to be $6. Therefore,
So, even
By
if
getting
you're
that,
breaking even, so it doesn't really work.
equating that to 6, you get n equals to 16.
Because
All right. All right, I'm going to stop here. It's a long lesson. You do have a